Video 24 pigeonhole principle. Pigeonhole principle. If k is a positive integer, and if k plus 1 or more objects are placed in k boxes then at least one box contains at least two objects. So this principle is called the pigeonhole principles. Suppose, for example, say k is equal to say 3, and there are 3 boxes. Then k boxes, if I take k equal to 3, there are 3 boxes, and I have to take objects either k plus 1 or more. So I take k plus 1 objects means number of objects equal to 4. If I place these 4 objects, all 4 objects can be placed in the first box itself. Then the first box contains at least 2 objects because we have 4 objects. If I place one object in one box each, I have 3. I am left with one more object because totally I have 4 objects. I have to place in one of them, so that box contains at least 2. So all 4 can be accommodated in one box. You can have 2 here, 0 there. So that means 2 boxes contain at least 2. All 4 can be, or 3, 1, 0, 1, 3, 0. Like that, in so many ways you can accommodate. But the condition is, what we are getting is at least one of the 3 boxes contains at least 2 objects. You cannot accommodate one object in one box and exhaust. If you keep one box with one object, then you left with one more object. When you place it, that box becomes having 2 objects. So at least, so this is the principle of pigeonhole principle. Generalized pigeonhole principle. Generalized pigeonhole principle. The objects can be taken as pigeons and boxes can be taken as pigeonholes. So pigeonhole principle. Generalize. If n objects are placed in k boxes, where n is greater than, we have to n objects, n is greater than k. N objects are placed in k boxes. Then what is the condition on this one? Number of objects must be more than the number of where n is greater than k. If n objects are placed in k boxes, then there is at least one box. Then there is at least one box contains at least, this is ceiling function, n by k, at least so many objects. So n objects are placed in k boxes. So this is the generalized pigeonhole principle. Okay. Now if you take n is equal to k plus 1, k plus 1 by k is going to be 2. So we will explain what is the ceiling function n by k. So square ceiling function x is equal to the smallest integer, least integer, the smallest integer greater than or equal to x. For example, ceiling function 5.1 is equal to, what is it? The smallest integer greater than or equal to 5.1. So x is 5.1. What are the integers greater than or equal to 5.1? 6, 7, 8, etc. These are all the integers greater than or equal to 5.1. Among these integers, what is the least, smallest? 6. So this is 6. So 6, 7, 8, etc. are integers greater than or equal to 5.1. Among these integers, the least one is 6. So 5.1 is 6. Greatest integer 5, ceiling function is going to be 5. Because all integers greater than or equal to 5 means 5 also included. Least is 5. So this is the meaning of this one. Okay. When capital N is greater than k, n by k is greater than 1. Therefore, the ceiling function n by k so this is greater than 1. Greater than 1 means all integers greater than 1 means this is going to be greater than or equal to 2. Because this is going to be minimum 1 point something. So 2. If it is 2 point something, you will get 3 greater than or equal to 2. Hence, that is one of the boxes contains at least these two objects. So this is what is called the generalized pigeonhole principle. Generalized pigeonhole principle means instead of k boxes, here also we have k boxes, here we have k boxes, but here the objects are k plus 1 or more. Here we have taken n objects, that n is greater than k. So this completes video 24.